right now, going through this once in 103 years pandemic together. And so the question I have for you is, do you think that's true? Do you think as a society, we've learned anything in going through COVID-19 that would help us have a faster response next time? And then more specifically, do you think that's true at NIH?
Absolutely. And maybe that is a little bit of the silver lining in this dark, dark period we have been through since January of 2020. Look, for instance, that's what we've learned about this platform for building vaccines called messenger RNA. That, of course, didn't come out of the blue. 25 years of hard work got to the point of beginning to contemplate actually designing and implementing such a vaccine for MERS. And then SARS-CoV-2 came along, and it was time to take what had been learned over those couple of decades and put it into practice. And look what's happened here with both the Pfizer-BioNTech vaccine and the Moderna vaccine based upon messenger RNA, achieving results that actually outstripped what most of us thought we could dare hope for. 95% efficacy and a really good safety record in a 2-dose regimen. And that's a platform, and it's a wonderful platform for being able to bring to bear on a new threat in a hurry, because you don't even need to have the pathogen in your lab. You don't have to have a virus growing in a plate or a bacterium in the plate. You just got to know the sequence of its genome. And then, overnight, as we did in January 2020 for SARS-CoV-2, you design that vaccine, and within weeks, in that case, it was less than 10 weeks, you are basically starting a phase 1 trial. I mean, absolutely unthinkable a few years ago. I have to believe that the mRNA vaccine approach is likely to be here to stay in a very important way for dealing with disease X. And it's not just vaccines, certainly diagnostics. One of the things NIH has been deeply engaged in, and I personally have spent countless hours on since last April, is to come up with ways to accelerate the development of diagnostic technologies that allow you to do point of care testing with a rapid response in a half hour or less of almost any kind of pathogen. Again, all you need to require is that it has nucleic acid. It's got to have DNA or RNA, or maybe it needs to have an antigen that you can detect. We have invested, thanks to the Congress, $1.5 billion in the space of just the last 9 or 10 months. And out of that have come no less than 28 really radically new technologies that make it possible to do that kind of testing. Some of them depend on things that we thought we might eventually try, like CRISPR-Cas, and they work. And this has made it, I think, feasible to contemplate for a future pandemic threat that those same diagnostic platforms could be readily adapted in order to quickly find out where is the disease and how to isolate those who are already infected. Obviously, something we wish we had had a better shot at with SARS-CoV-2 back a year or more ago.
You mentioned the investment that Congress made and how important that public sector work has been. And of course, the private sector has had a big role too in diagnostics and therapeutics and vaccines. So how important do you think the private sector has been to the success of these efforts?
It has been absolutely essential, Suzanne. If there was ever a time where we needed to get everybody with scientific capabilities around the same table and work together, this has been it. And that's another lesson that we can carry forward. I am happy to point to this partnership called ACTIV, ACTIV, which stands for Accelerating COVID-19 Therapeutic Interventions and Vaccines, as something that got put together a little less than a year ago, recognizing that our therapeutic efforts at that point were not very well coordinated. There were a lot of small trials, many of them focused on hydroxychloroquine, which turned out to be a dead end. And we didn't have a coordinated way to prioritize all the therapeutics that might potentially be beneficial, the small molecules for repurposing, the monoclonal antibodies that were starting to get developed. That led to, through this partnership, rapid development of master protocols so that it would be possible to quickly establish trials that you knew were going to be rigorous and would give a good answer and the FDA would be comfortable with, as well as doing the prioritization of the therapeutics, and as well as actually pulling our clinical trial networks together in a way that made them more readily adaptable to launching quickly a trial on some new therapeutic agent, which hadn't really quite been done before. So we learned a lot from all of that. And this was a consequence of bringing together 20 pharmaceutical companies, the NIH, the FDA, the CDC, all managed by the Foundation for NIH with its remarkable program management skills. And it continues. We'll be meeting, in fact, tomorrow for our monthly leadership team to figure out exactly how best we can do this in the most effective way.
Just before we bring in our other guests, I want to ask you one other question, and I'm sure the audience will have more for you in a minute. What other public and private sector investment should we be making now to make sure that we're ready to defend against disease X?
Well, one thing that we didn't have time to do was to develop small molecule antiviral drugs. When you look back at HIV, how did we ultimately go from the original repurposing idea, which was AZT, and actually get drugs in combination that are highly effective in preventing death from that disorder? That took a big investment, a lot of time, a partnership with industry. We need to do that also for this short list of viral types, coronaviruses, flaviviruses, that we think might in fact be the likely candidates. We're doing that right now for coronaviruses, but it didn't happen quickly enough to deal with the last 12 months because that is a longer lead time to identify an appropriate drug target, go through all of the high throughput screening, the medicinal chemistry, the testing in animals, and ultimately the human clinical trials. But we ought to have a better library of those antiviral compounds ready to go. And I think that is something now that needs a big investment across the world to get ready for the next one.
I appreciate that. And I still have more questions. And as I said, I'm sure the audience does too. But let's first bring in our other two panelists, and then I'll come back to you. Why don't we roll the tape from this morning's conversation with Dr. Grossi, please? Dr. Grossi, tell us, what is the International Atomic Energy Association and what is its role in disease control?
Well, first of all, thank you very much. It's great to be with you, to see you again, and all the others who are listening in or watching us. It's a great privilege to be able to talk to you and to explain a little bit of what we are trying to do here. The IAEA, for many, is mostly, not only, I suppose, but mostly known for our role in weapons, nuclear weapons inspections or non-proliferation. You may have seen the name of the IAEA being mentioned when reporting about things going on in Iran or in North Korea or in other parts of the world, where we basically check that nuclear material, which is normally sitting and fueling nuclear power plants or in health facilities for medical purposes like cancer control and other things, or laboratories, is sitting, and we are checking that this is not misused for making bombs, to put it in very simple, direct terms. But the IAEA does much more than that. The IAEA is also working on the applications of nuclear science and the technologies which are connected to it. And within this area, we are working, as I mentioned just now, on many things related to nuclear medicine, radiotherapy, oncology, where, of course, radiotherapy and nuclear medicine are very common. But not only that, by using nuclear techniques like irradiation, for example, we help many countries protect their crops. By using isotopic tracers, we help detect nanoplastics in the seas, protect the environment, fight against ocean acidification, a host of issues that are related to human development writ large, so to speak. So the IAEA has this double dimension. So on the one hand, being this institution that is trying to prevent the spread of nuclear weapons, which is its one of the basic roles, also checking that nuclear facilities in the world are operated in a safe and secure manner to prevent incidents or accidents like the ones that you are aware and very famous, like what happened 10 years ago in Japan, in Fukushima, or in Chernobyl, in what was the Soviet Union back in the day, or even 3 Mile Island, closer to you. So we have all these missions, but today, I believe, Susan, we are going to concentrate on this other side of the IAEA, which is the one that tries to help countries face different challenges, from pandemics, and I think we are going to talk about that, to nuclear medicine or food security or many other things. We have 173 member states. We are not a part of the UN, but we are connected to the UN. We are an international organization, and our headquarters are in Vienna, in Austria. So I'm here to try to explain some of these things and to see whether it would be possible to join hands and work together on many of the things and missions that I'm sure basically are the same from our different perspectives and roles.
Well, what an important organization and mission, and how lucky for the world that you've committed your talent to performing this. So talk to me a little bit. I've been fascinated by the Zodiac program. Can you tell our audience what that is?
Well, yes, this is connected to the current big challenge that we are all facing, the pandemic. When I came to office, I started my present role at the end of 2019, and soon thereafter, you remember January 2020, February, March, we were confronted with this incredible challenge of the COVID-19 and the pandemic. One may ask, okay, yes, perfect, but what does the IAEA have to do with SARS or with COVID-19? But the answer is quite a lot, and I will try to tell you why or how, and then, if you allow me, then explain what Zodiac is. The first thing is that because of this scope and this ability of nuclear sciences, technologies, and nuclear-derived technologies to be useful in so many areas, there is one thing which is quite obvious, and many of you may have been hearing about this, the RT-PCRs that are so important for diagnosis, for early and faster diagnosis, are a nuclear-derived technology. And many countries, in fact, 128 countries, almost 130 countries, turn to us to help them to get RT-PCRs. It is important to American audiences, even educated American audiences like you, and people that know the world and have been traveling a lot. It is always important to be reminded that there are places where they don't have one single RT-PCR, which is commonplace in any health institution in America and in many other countries as well. So many countries came to us. Can you help us? Can you give us this? So we raised money. I raised money, apart from, because this had to be paid for, and we didn't have any provision for this in our regular budget, naturally. So the United States helped, and many other countries. And so we dispatched these RT-PCRs, which were, and continue to be, paradoxically, continue to be very important, because at whichever stage of the pandemic you are, you need to have an idea of how well or not so well you are doing, and how many people are infected and at what pace. So we did this in the beginning, of course, and that kept us extremely busy, but very motivated and inspired to try to help as many as we could. But there was something else. And this brings me, Susan, closer to your initial question about Zodiac, what Zodiac is. I sat down with my team here in Vienna, scientists, technologists, knowing that for many years, the IAEA had, together with the Food and Agriculture Organization, the FAO, you may have heard, in Rome, a program looking into research on zoonosis, precisely, using nuclear techniques, isotopic tracers, and other technologies available. We have been working on these areas, albeit at a relatively small scale. So immediately it hit me, it came to mind that given the circumstances and the problem, we could try to see whether those small activities, those small R&D activities, could be perhaps scaled up to see whether we could help in the family of efforts which are being deployed and were being deployed nationally and also internationally. And I will talk about about this a little bit later, if you want, about the partnerships that do exist. The idea being that we would see what we had, and what was that we had? We had, for example, something which is quite unique, and is a network of more than 300 veterinary laboratories all over the world, in Southeast Asia, in Central Africa, in the Caribbean, in South America, everywhere, that were working with us already, as I said, at a smaller scale. So with the scientists here, we designed a program which is basic, with the idea basically to provide, to beef up the equipment, the capabilities of all these laboratories and institutions that already are linked between them and with us here in Vienna, to give them the ability to be sharper, to be faster in the early identification of pathogens, zoonotic pathogens, which, as you know, are the ones that move from the animal realm to humans, and which are basically the type of phenomenon we have seen with COVID-19. So we had a design of the project. We talked a lot in the course of last spring, year before, and the summer, and we put together this Zodiac, which stands for Zoonotic Disease Integrated Action. We presented it to our member states because they are like the shareholders, if you want, if we were a private company, at the board of governors, and it was agreed. And so we have started working with all these laboratories, institutions all over the world to, on the one hand, as I was saying, give them the equipment, the means, the training, the capacity building that they need to be better at what they are doing, but also, and more importantly, or equally importantly, perhaps not more importantly, but equally important, to provide something which, if I may venture my own personal opinion, was lacking when this current pandemic started, which is a platform for permanent online communication among these labs. One of the biggest deficits, and perhaps a deadly one, we had in the beginning of this current crisis was the lack of information, the lack of transparency, the fact that people in the Western Hemisphere were not aware of things that were happening in Southeast Asia or in other parts of the world. And this is not the first time. In fact, this is not the first time. We've seen this before. We've seen this with H1N1. We've seen this with the first SARS. We've seen this in the Middle East with MERS, which is the regional variant of SARS. We've seen this with Ebola and with other zoonoses that are more or less known. So, in a nutshell, Susan, in a nutshell, Zodiac has the vocation and the potential to become a very important instrument and element. It's not the key to the solution. There is none, and there are others working on this in the world from their own particular perspectives. But this is a very focused nuclear technology-based instrument that we hope is going to be very instrumental in preventing a next pandemic. So I hope with this explanation you have a good idea, and those participating with us this morning know what Zodiac is.
Thank you very much for that. Let me ask you a question. If you're talking to U.S. businesses who might be with us watching this morning, what can they do to help? I mean, this is a really important effort that could help stop the spread of the next pandemic. What is it that we could be doing to help those efforts?
I think the American business community can do a lot. In this project, we are trying to reach out to our traditional donors, member states, of course, but at the same time to private and business communities all over the world for a couple of reasons. The first is we believe that in the business community in the United States, many companies and enterprises have important and robust social responsibility policies that could be applied. At the same time, we believe that it is in our own interest, and I say it in general, for all of us, all over the world, in America and in the rest of the world, to see to it that we put resources in those projects that may help prevent a next pandemic. And this is exactly what Zodiac is. So I believe that the American business community has a tremendous impact and could help this come in line much faster when they help us.
Well, we can't thank you enough for being willing to talk to our audience today, Dr. Grossi, for the important work you're doing, and we're looking forward to a strong partnership. So thank you very much.
I thank you. I thank you.
We're delighted to now bring in Dr. O'Toole. Thanks so much for being here. And just for our audience that may not be aware, tell us a little bit more about In-Q-Tel.
Sure. Well, In-Q-Tel is a very unique organization. It was founded about 21 years ago by the Central Intelligence Agency to enable them to have rapid access to innovative technologies, at the time, particularly software and computer science technologies that were being born out of small companies in what we now call Silicon Valley. And IQT uses venture capital practices to discover, adapt, and accelerate use of these innovative technologies by national security agencies. We now deal in all kinds of technologies, including biology and biotech, and we serve 9 different national security agencies as customers. We don't invest for profit. We invest to have impact on our customers' missions. And because we talk to about 1,000 different small companies internationally every year, and make about 50 investments, which is a very rapid pace, although our investments are relatively small. We also gain a great deal of situational awareness about technology trends, capabilities, and emerging technologies that may prove particularly exciting or disruptive.
And so that's a lot of intelligence you're gathering. Where do you end up? What keeps you up at night?
Well, what keeps me up at night is the number of significant crises and challenges going on around the world, and the difficulty that our social institutions and government have in dealing with them efficiently and rapidly. It may be that disease X emerges in the next couple of years and we have another pandemic to deal with. It may be that climate change causes mass movements of people that has to be dealt with. It may be that we have food security problems around the world causing lots of civil unrest. But in any case, we need to develop better mechanisms to bring the science and the technology and the organizational know-how that exists in different parts of every nation and around the world and knit it together and make it into, working organizations such as those that Dr. Collins described. And we need to do that very efficiently and across a very wide range of problems. And we need to get much better at using technology as part of the tools to solve some of these problems.
Well, speaking of that, you, as I understand it, you created your organization's Be Next initiative, which is focused on bringing biotechnologies to bear on epidemic outbreaks, right? And so tell us about why you believe biotech can improve epidemic, not just management, but detection.
Well, we created Be Next 6 years ago because we recognized that biology was moving ahead very, very quickly and in powerful ways, and was likely to become a disruptive force, not just in biomedicine, but across a host of industries, including material science, biomanufacturing, environment, agriculture, and so forth. And to narrow our scope, we focused on technologies that could help us detect, manage, and quench pandemics of infectious disease. We divided our technology architecture into 4 big chunks, which we think are necessary to deal with pandemics. One is detection and diagnosis. The second capability that you need is protecting the well. The third is treating the sick. And the fourth, which runs through all of them, is data collection, analysis, and sharing. Detection of an epidemic or an emerging epidemic is very difficult because, as Dr. Collins said, it may come from anywhere and be anything. We thought that the H1N1 flu, or that the next big flu outbreak of a novel strain of flu was likely to come out of China. In fact, H1N1 in 2019 seems to have emerged from Mexico. So seeing spillover, that jump of a new pathogen from an animal to humans, for example, is very difficult. But we can get much better at detecting small clusters of similar infections before they become large epidemics, let alone pandemics, and stopping them in their tracks. To do that, we need a number of tools, starting with rapid point-of-use diagnostics, as was mentioned earlier. The technology for these diagnostics has been available for quite some time. It was really market forces and lack of investment in the translation of basic science into workable products that has put us in a position where we're still waiting for the kind of point-of-use rapid readout home diagnostics that would really make a difference in this pandemic. In the future, the capacity to make those diagnostics and distribute them widely in smaller outbreaks would be very valuable. And I could go on, but that's where I would start. And of course, our big failing in this epidemic, which has had many bright spots, as Dr. Collins articulated, has been in data. In America, we have a very fragmented health system. Public health is fragmented by state, county, and local jurisdictions. And bringing accurate data, timely, reliable data together in something close to real time, so that we have situational awareness, we know what's going on, and we can deal with it more effectively, has been our big Achilles heel. And that's going to need a lot of attention in the future.
Before you joined In-Q-Tel, you served as Undersecretary for Science and Technology at the Department of Homeland Security. And I wonder if you might talk for a minute, not just about these diseases from a public health lens, but also from a national security lens. So why is preventing disease X important to national security?
Well, I think that's obvious. A big pandemic is not only a tragic event in terms of the loss of life, as we've seen, over 500,000 Americans have died from this disease. We'll never know what the global loss is. It's been extraordinarily disruptive, not just to our economy, which is, of course, the basis or one of the bases of our national power. It has frayed the fabric of our civil life, making it harder, I think, to come together on important issues that we need to deal with. And it's also, I think, demonstrated how another pandemic could impede even military action. We had to take a whole aircraft carrier out of service because of widespread transmission of COVID early on in the pandemic, and dealing with the threat of transmission and sick troops has been an ongoing concern for the military. If anything, I think this pandemic should show us that biological threats, whether natural or deliberate, have got to be a core concern of national security. We have to, in the next decade, broaden our idea of national security to include not just direct military threats to the United States, but to also include things like highly consequential national disasters that could really impair our ability to use national power.
I think one of the things that might make it less obvious to the uninitiated is this felt like a global pandemic. So didn't it kind of hit everyone? And I think the points that you're making is that it could be uneven, it could be uneven in the future, et cetera. But going to kind of a basic level, where do you think we stand vis-a-vis our adversaries on our preparation?
Well, when we talk about adversaries these days, most people are talking about China. I think of biothreats in three categories. There are naturally occurring epidemics and pandemics, such as the Ebola outbreak in West Africa a few years ago, and such as this coronavirus outbreak. And we had a close call with the SARS outbreak in 2003. And we're going to continuously be worried about flu pandemics because that virus stays around and evolves and mutates very quickly. The second category of threats would be deliberate attacks, bioattacks, which I know sound like science fiction to many people. But as the world of biotechnology expands and the market for the goods that biotech can produce, which are, as I said, go way beyond biomedicine products, as that desire increases, there's going to be a lot of people who know how to manipulate biology. We had a program, a military program in the 1960s that created bioweapons that were equivalent to nuclear weapons in terms of their lethality and wide area coverage. So we have to consider it a possibility. Thirdly, and what I think is the biggest threat to the United States, because we have such capacity, we have such amazing science, as Dr. Collins pointed out, and we have such capable private sector companies. I think the biggest threat would be America's failure to compete in what I think is going to be a global bioeconomy. I don't think we've woken up yet to how important biology and biotech is going to be economically across multiple industries. And China is investing very heavily, both in basic research, but also in translating the science into useful products. We have been less forward-thinking and less proactive in translating biological insights into products. Hence, we didn't have the mRNA vaccines when COVID started. We caught up because of this remarkable alliance between government and the private sector. But we could have had them when COVID started. It wasn't a technological hurdle that we had to cross. So I am very concerned about the failure of government in particular to focus on the coming bioeconomy and what it's going to take to allow our private sector and our public institutions to continue to compete.
It's such an important point you're making, and it makes me immediately want to say, what can the chamber do? What do you think the business community could do to help us move in the right direction?
Yeah, make noise. I think, as Dr. Collins said, a lot of the successes in fighting COVID were due to the ingenuity and the very powerful efforts on the part of the private sector. I think mistakes were made in some areas in not fusing those two pieces of our world together faster and more efficiently. But if you look around the response to the pandemic today, you have, the innovation that we're talking about in both therapeutics, vaccines, and diagnostics emanated from the private sector. The basic science was definitely a consequence of almost $1 trillion invested by the government in basic bio research since World War II. But as I said, that translation needs more attention. We need more investment, public investment in infrastructure that could be used by all of the private sector and academia. We need to strengthen our universities, which is one of our real strong points in America. We need to make sure that every child has some basic literacy in science and biology, which is a problem for us now as we try to persuade people to take the vaccine, for example. But the private sector has to be, I think, more aggressive in pointing out what might be possible and what roles government might have to play in making more innovation come to light and then, become real.
Okay, I could ask you about 11 more questions, but we still have questions for Dr. Collins too. So I'm going to pull you both on the screen and start to go through. I put my glasses on so I can read this fine print for some of the audience questions that are coming in. And so Dr. Collins, let me start with you. An audience member is asking, what is the level of international cooperation on the effort to extract the lessons from COVID-19?
I think it's good, but it could be even better. I will tell you honestly that the last year's withdrawal from participation in WHO was not a helpful decision on the part of the United States, although scientists continued to work closely together despite that official position. It is wonderful now to be back into that particular environment where we do have the chance to share information quite freely and regularly. This morning, I spent some time on a Zoom call with one of the directors, one of the directorates of the European Commission. On Friday, I will be part of something called the Heads of International Research Organizations, which represents the lead individuals in the funding agencies across the world that support more than 90% of the public support of biomedical research. And guess what we're talking about? COVID-19 and lessons learned, and what should we be thinking about to get ready for whatever's coming next. So I think the connectivity is pretty good, but it could always be better. The good news is scientists are traditionally really interested in interacting with each other and don't care too much about country boundaries or too much about any kind of areas of limitation in that regard. If there's a chance to learn more, to go faster, that's what we want to do. And I think that's really important right now. And I will certainly be personally encouraging as much of that as possible.
A kind of related question for Dr. O'Toole. What are the barriers to that type of cooperation? The question specifically is, what barriers exist that deter scientists in all countries from working more fully together?
Well, I think as Dr. Collins said, scientists are pretty collaborative, and they are doing their research and publishing in international groups to a greater and greater extent. I think something that would help would be more scientific literacy within the governments, so that you didn't, the politicians didn't start talking to scientists on day 3 of the crisis, but got to know them and worked with them and had a chance to become confident of their judgment on a day-to-day basis. In the United States, for example, I would like to see it become much easier for scientists to join the government for a couple of years and then go back to their universities or their corporate research labs. I think we need an infusion of scientific talent into the US government for sure. And I believe, at least in the countries I'm aware of, that would be true across much of the world. You know, the other issue, of course, is trying to separate the science, the facts of the matter, from the politics of the matter. And that's going to take long effort and constant attention, I think. We just need much more infusion of scientific literacy into the daily dealings of government.
Sure, agree with Dr. O'Toole on that. Let me add one other barrier that is getting in the way right now, and it reflects something Dr. O'Toole said earlier. It's about data access. Unfortunately, at this moment where access to data is so critical, especially when you're trying to size up a coming pandemic, there are, in many instances, very self-protective policies being put in place that actually I don't think serve the needs of the planet or even of that country particularly well, but end up making it difficult for scientists to collaborate with each other. Europe, for instance, has their so-called GDPR, which has made a really difficult time for many collaborations, some of which have been going on for years or even decades, and have which pretty much been stopped cold because of this very restrictive idea about sharing information, even with full consent. So I think that's something that needs to be looked at a lot harder, that this kind of ability to share data is critical for the future, and individual countries trying to lock that down is working in the wrong way.
I think that's an important point, Dr. Collins, and I took a note. There may be things we can help with on that. While you have the microphone, Dr. Collins, this is for you. You've said, and I think this is related to something Dr. O'Toole said a second ago, you've said it's important for us to recognize that our future depends on the fact that there is objective truth and it can be established by science. We see some wild conspiracy theories out there right now around COVID-19 vaccines. What does it mean for our long-term preparedness if this kind of deep skepticism and misinformation continues to gain a foothold?
Well, it's a deep concern, and it's true not just in the US, where it seems to be particularly obvious right now, but in many other parts of the world as well. I didn't quite see this coming, at least not at the level of severity that we see now. where actually people are not looking to see what the evidence is before deciding what they believe. We, after all, have made our progress in this country and in this world based upon evidence and figuring out what's really true and what is not. And to have a circumstance arise where facts often seem to fall in the face of opinions, oftentimes the opinions based upon something that turned up in social media, is not a pathway that's going to be good for our country or our world. And again, I think this comes back to what Dr. O'Toole said, that we've done a poor job of achieving scientific literacy amongst our population. And so I think there is still a genuine lack of appreciation that actually evidence matters, and that just because somebody expressed an opinion who seemed to be somebody who had some kind of a spokesperson role doesn't mean that that's something that you should necessarily accept as true. The truth really does exist, and it really does matter. And if we start slipping away from that, that's heading us into a very dangerous place.
Dr. O'Toole, here's a question for you. How would you grade our response to COVID-19? Are we doing better or worse than you would have expected based on the war games you led for the US government?
Well, 6 months ago, I would have said that we are doing worse than I ever would have imagined, based on having spent 20 years of my life trying to imagine a pandemic and prepare for it. But I think, as Dr. Collins said earlier, the availability of these fantastically effective vaccines within a year of sequencing this novel virus no one had ever paid attention to before is going to stand as one of the major medical accomplishments in history. And I think we are getting our act together. The numbers of cases are leveling out. The numbers of deaths are going down somewhat, although the toll is still horrifying. I think the next phase is going to be trying to grapple with the fact that we really are all in this together as a planet. And until we can get control of the virus in all the countries of the world, we still have a really major problem that is going to impact our normal lives and economies. So I think that will be the next phase. But I have very mixed views about where we are. I think it's getting better. I think this problem of getting people all on the same page about what is real and what the problem is a very deep problem for all of us, not just for the politicians and not just for the scientists, but for the leaders of our community in all of their many flavors and colors. And I think it's going to take years to make significant progress on that score.
And I think it's true beyond the pandemic, right? Not just true.
Absolutely.
Yeah, I mean, it's something we're all coming to grips with. I think it's a really important point that you all have made today, way beyond COVID-19 or even disease X, but that truth exists, that science can help find it, that evidence matters. I think these are really, it's amazing that we have to declare that as news, right?
Yes. Yeah.
Well, listen, we can't thank you enough for being on the show. And I'd like to keep the dialogue open so that you can help the business community and the chamber think about our role in preventing disease X and in increasing access to data, to more scientists in government, to some of the specific suggestions that you had. I would hope that our teams can keep talking and that we could be part of the solution. Thank you for being here today.
Thank you. It's been a pleasure.
Thank you. And to the audience, thank you so much for joining us. If you've missed any of our previous discussions, you can find them at uschamberfoundation.org or on YouTube. We will have our next program on April 15th and look forward to having you there. Somehow we've picked St. Patrick's Day and Tax Day, so at least it'll be easy to remember. We're also starting a new sub-series that you might find interesting, and I think it's starting, let me check, April 5th. This will be called Path Forward Ask Me Anything, where every day that week we're going to bring forward a different expert so that you can ask your questions on this disease, on disease X, on prevention, on the vaccine, etc. So we will look forward to seeing you the week of April 5th. In the meantime, where's my mask? Wear your mask, and something new. We're going to say, make sure if you can get your vaccine that you do, and that you encourage your loved ones to do the same. So take care of yourselves and each other, and we'll see you soon.